You wrote the rule down. Your agent read it. It did the thing anyway. If that has happened to you, the useful thing to know is that nothing was ever stopping it, and that is not a bug report. It is how the mechanism works. Here is the vendor's own documentation on the page about memory. Quote, Claude treats them as context, not enforced configuration. To block an action regardless of what Claude decides, use a pre-tool use hook instead. End quote. So the thing people call memory, and the thing people call rules, and the thing people call project instructions are all the same thing mechanically. They are text that arrives in a context window. Text does not enforce. In this video, I will show you exactly how that text is delivered, exactly what a model sees when it decides whether to use one of your tools, and exactly what does enforce because something does. Who is telling you? We build and sell a memory layer for AI agents that connects over MCP, so we are a vendor in the category this video is about. Nothing of ours is on screen. Every quote is from public documentation, a public specification, or a person who published what they found. And the honest conclusion of this video partly argues against buying anything from us. Before the mechanism, 4 people. All 4 are public, all 4 are dated, and both of the issues are open as I record this. The first is titled, quote, Persistent memory rules are decorative, Claude ignores them before destructive actions, repeatedly across sessions. End quote. Inside it 3 sentences, quote, The rule was in memory. Claude had read it. Claude pushed directly to main 3 times. End quote. The second from a different person on a different day. Quote, Memories are written but not acted on. End quote. The third on Hacker News. Quote, Literally anybody with a CLAUDE.md has seen the behavior over and over and over. End quote. The fourth is about a different vendor's tool entirely, which matters because this is not one product's problem. Quote, Even after I have explicitly emphasized the same constraints more than 20 times, it fails to respect project-specific rules, loses track of context, and makes decisions that actively put the structure of my project at risk. End quote. 4 people, 2 companies, 1 shape. The instruction was stored. The instruction was read. The instruction was not binding, because storing something and binding something are different operations, and only one of them was performed. Here is the mechanical answer, and it is on the same public page. Quote, CLAUDE.md content is delivered as a user message after the system prompt, not as part of the system prompt itself. Claude reads it and tries to follow it, but there's no guarantee of strict compliance. End quote. Read that again for the part people miss. A user message, not a system instruction, not a configuration value. A message in the conversation arriving the same way the rest of the conversation arrives and competing on the same terms as everything else in the window. Which means the strength of your rule is the strength of a sentence, not a gate, not a check. A sentence next to other sentences, some of which are your actual task, and some of which are a file somebody else committed. Now the part the audience found first before any vendor explained it. Someone put a proxy between the client and the model, read what actually goes across, and published it. Your instructions arrive inside a wrapper. The wrapper ends with this sentence. Quote, important, this context may or may not be relevant to your tasks. End quote. That is the last thing the model reads before your rules. Not a mistake and not hidden. It is one sentence doing an obvious job. The client cannot know which of your instructions matter for the request you just typed, so it says so. But sit with what it means for the sentence you wrote. You wrote never push directly to main. It arrives as a user message, after a note explaining that it may or may not be relevant. The same shape appears one layer down with tools. You connect a memory server. The client says connected. The tools are listed, and the model never calls them. So look at what the protocol says a tool description is for. This is the tool interface in the specification. The description field carries a comment, and the comment says, quote, "This can be used by clients to improve the LLM's understanding of available tools." It can be thought of like a, quote, hint, unquote, to the model, end quote. They're scare quotes, not mine, a hint. And look at the field itself. Description, question mark, string. The question mark means optional. A tool can be registered with nothing but a name and an input schema, and the specification is fine with that. The only required member of this interface is the input schema, not the description, not the annotations. One thing this chapter is not about. Search this question and you will find bug reports where tools never reach the model at all. A server connects, the list comes back, nothing surfaces. Those are real and they are closed and they are a different failure. This chapter is about a tool that arrived correctly and was not chosen. 3 things: a name, a schema describing the arguments, and a hint written by whoever wrote the server, which may not exist. That is the whole basis for the decision. There is no relevant score, no priority field, no required flag, no this one matters marker. The author of the server writes a sentence, and the model reads it alongside every other tool's sentence and decides. There is one case where the tool genuinely is not there, and it is worth separating because it looks identical from the outside. In VS Code, MCP tools are active only in agent mode. In Ask mode, the panel still shows them, and the schemas are never put into the context. So the model is not declining. It cannot see them. Absence and decision look the same from your chair, and they have completely different fixes. Something does enforce, and the same documentation says which. Quote, "Settings rules are enforced by the client regardless of what Claude decides to do. CLAUDE.md instructions shape Claude's behavior, but are not a hard enforcement layer." End quote. And here is how that works, which is the most useful sentence in this video. A deny rule does not ask the model to refrain. Quote, "As a deny rule, both forms remove the tool from Claude's context." End quote. Removed from the context. The model is not told no. The model is not shown the tool at all. You cannot call what you cannot see. Deny also wins over allow, unconditionally. Quote, "A broad deny rule like bash oz star blocks every matching call, including calls that also match a narrower allow rule like bash oz s3ls, so a deny rule can't carry allow list exceptions." End quote. So there are 2 different operations, and we have been using one word for both. A memory adds text to the window asking for something. A permission rule subtracts a capability from the model. One is a request, the other is arithmetic. Which brings me to the part where I argue against my own product. If what you need is for something to not happen, no memory layer will do it. Not ours, not anyone's. Storage is not enforcement no matter whose storage it is, and a vendor telling you otherwise is describing a feature that does not exist. Use a hook. Use a deny rule. Those run outside the model and they do not care what it decides. And if what you need is for the same instructions to be in front of the model every session, a file in your repository does that. It is free, you can read it, your team can review it in a pull request, and it is already installed. For a lot of people, that is the whole answer, and there is nothing to buy. A memory layer is for a narrower thing. Facts that accumulate, that you did not write by hand, that need to be there in a session you have not started yet and in a tool you were not using at the time. That is a real problem, and it is not this one. Last thing, and it takes 2 minutes. Reading and obeying are separable, so test them separately. First, ask it to state your rule back to you. If it cannot, the rule is not arriving, and that is a delivery problem. Wrong file, wrong scope, wrong directory, excluded by a setting. Fix it there. Second, and only if the first one passed, put it in the situation the rule governs and watch. If it states the rule correctly and then does the thing anyway, delivery works and nothing is enforcing, which is the entire subject of this video. That second outcome is not a malfunction. There is no obedience layer to malfunction. There is a context window with your sentence in it, competing with everything else in there, and a model deciding. If the decision has to go your way every time, the decision cannot be the mechanism, and you need the layer that runs outside it.